Now I want to talk briefly a little bit about some lens properties that help describe this. The first one is going to be called f-number or f-stop. Sometimes you'll hear f-stop referred to quite often. Now, this f-number is just the ratio of the focal length divided by the diameter. That means that a large f-number is a small diameter. And they tend to come in powers of root 2. So, for example, it goes from 1.8 and 4 and 8 and 16 are various f-numbers. You can see the corresponding size of the diameters so that a low f-number means a large lens and a large f-number means a small little hole in here. So the way they write them is a little weird. They don't say f-number equals. They typically write it as f divided by 10. So that would mean f10 is f divided by 10. Now, f-number is related to brightness because the diameter is related to brightness. The larger the diameter is, the more light then comes in. It's also important to note that the focal length is related to brightness as well, because if it's a smaller focal length, then you end up having a physically smaller image, which means that the same amount of light that is coming in through the camera is being concentrated into a smaller area, and therefore is more intense, because the intensity is the amount of energy hitting a surface every second divided by the area of that surface. So it's a density. The more dense the light is, the higher the intensity is. If you double the f-number, it ends up having 4 times smaller the intensity. So that if you do a square root 2 times the f-number, you have 1/2 the intensity, which is why these cameras typically are set with f-numbers that are multiples of square root 2. The intensity is directly proportional to the diameter squared over the focal length squared, which is the same thing as being 1 over the f-number squared. So the listing of the f-stops, as you can kind of see on this camera, go from 1, 1.4, 2, 2.8, 4, 4.6. These are all multiplying the next one over by square root 2, so that the brightness is going down less and less and less in factors of 1/2. Now, one of the reasons this is important is because the brighter the image is, the less time you typically need to shine the light on the screen in order to record the image. And the shorter the time it takes to record the image, because it'll expose the screen for either a CCD in a digital camera or the film for a limited amount of time, and the shorter the time is, the less blurring you have due to motion. So usually people think of f-stop as really related to how quick the camera is, how long the exposure is. And since a larger f-number is a dimmer image, that means you have to take longer time with the higher f-numbers. So a low f-number would mean that it is a faster image, like a quick image. So if you want to take a motion of something that's moving fast, you may want to have a small f-number. One other thing, this is going to be related to our discussion in optometry that will be coming up, is something called optical power. We've been describing the lenses in terms of the focal length, which is a very useful way of describing them, but it's not commonly how it's used in optometry. Most often, if they tell you the type of lens you have, they tell you the optical power. Optical power is just 1 over the focal length. So if you have, for example, a 1/2 of a meter focal length, then your optical power is 2 inverse meters. Now, an inverse meter is a diopter, so the unit is usually referred to as a diopter. So if your focal length of the lens that you are given, prescribed by your optometrist, is 1/2 of a meter, then your prescription would be positive 2 diopters. And for people who have prescriptions, they're usually listed along the terms in terms of diopters, positive 2, negative 1.7, and so on. I should note that the nice thing about optical power is that larger optical power means a stronger lens, meaning that it bends light more. If you have to get stronger glasses, so to speak, you're going to have a larger optical power.